Solubility of alcohols. In water, if we look at the solubility of alcohol in water, means in polar solvent. Water is polar molecule or polar solvent. Alcohol is polar compound. So now we are looking at the solubility of polar compound, which is alcohol, in polar solvent, which is water. So if the alcohol has less than 5 or equal to 5 carbon, the alcohol is water soluble. It capable to form hydrogen bond with water. That's why it is soluble, because it can form hydrogen bond with water. Alcohol can form hydrogen bond with water if the carbon in the alcohol 5 or less. But if it is more than 5, 6 or above, the alcohol is water insoluble. Because it is the non-polar alkyl portion. Non-polar alkyl portion or hydrophobic portion. Here, the carbon part, all this here carbon part here, it is too large to dissolve in water. This OH group is hydrophilic portion, can form hydrogen bond, but you have very long carbon hydrophobic portion. So that's why if the number of carbon is 6 or above than 6 carbon, the alcohol is water insoluble due to large hydrophobic portion here. The solubility of alcohols in water gradually decrease as the hydrocarbon portion or hydrophobic portion of the molecule lengthens. Means if you have more number of carbon, the solubility of alcohol in water will decrease. Here, diol. If you look at here, diol with 6 carbon, 2 OH group, so diol with 6 carbon, and here 6 carbon as well, but only 1 OH group. The alcohol, which has 2 OH group, is more soluble than the alcohol which has 1 OH group only. For alcohols with comparable molecular weight, means the number of carbon is the same or almost the same, the solubility increases if you increase the number of OH group, because the molecule with more OH group can form more hydrogen bond. This one 1 OH group only. This diol 2 OH group. 2 OH group can form more hydrogen bond with water. So that's why more OH group more soluble, because more hydrogen bond can be formed with water. The solubility of alcohol in organic solvent. Okay, organic solvent is non-polar solvent. Alcohol, polar compound. Organic solvent, non-polar solvent. So if you look at polar with non-polar, it is polar with non-polar, it is insoluble. But you look at the hydrophobic region. In the alcohol, it has hydrophobic region. The carbon region. Here, the carbon part. The carbon part makes alcohol soluble in organic solvent. Why? Because it can form London forces or van der Waals forces. The alcohol, here the hydrophobic region of alcohol, can form van der Waals forces with the organic solvent due to the presence of hydrophobic part. This hydrophobic region is soluble in organic solvent. So that's what it makes alcohol soluble in organic solvent, not the OH part. The carbon part is soluble, okay, due to the presence of hydrophobic part. So in conclusion, we can say that alcohol is soluble in water and it is also soluble in organic solvent. Okay, if organic solvent, it is soluble because it can form van der Waals forces with organic solvent with the hydrophobic region. But in water, the OH part can form hydrogen bond with water. That's the difference, solubility of alcohol in water and in organic solvent. Next, we look at the boiling point and solubility of phenol. Phenol has higher melting point and boiling point than alkanes, arenes, and aryl halides of comparable molecular size due to the presence of strong hydrogen bond. So here phenol, it has OH group. Alkane, arenes, aryl halides don't have OH group. So that's why this OH group makes it has hydrogen bond. Okay, that's why it has higher melting point, boiling point if you compare with alkane, arenes, and aryl halides. But phenol is slightly soluble in water. It is slightly soluble in water, but has higher solubility than alkanes, arenes, and aryl halides. Alkane, arenes, and aryl halides cannot form hydrogen bond with water. But phenol, it can form hydrogen bond with water because it has this OH group. Okay, it has this OH group in phenol, so it is soluble in water compared to alkane. Alkane does not have OH group, so it is insoluble in water. Same goes for arenes and aryl halide. These two don't have OH group, so these two don't have hydrogen bond with water.